Have you ever wondered what existed before the Big Bang? Picture this, a moment when the universe as we know it was not yet born, a time, if we can call it that, before time itself had begun. This is where our journey into the cosmos begins, at the very edge of our understanding. The Big Bang, a term we're all familiar with, is widely accepted as the starting point of our universe. A colossal explosion, an eruption of energy, space and time, giving birth to galaxies, stars, planets and ultimately us. But the question that still baffles us, that sends shivers down the spine of even the most seasoned cosmologists, is what came before. What was there before the Big Bang? It's a question that pulls us into a whirlpool of scientific inquiry and speculative theory. It's a question that has kept philosophers and scientists awake at night for decades. It's a question that, if answered, could unravel fundamental truths about existence itself. To the human mind, accustomed to the concept of cause and effect, the idea of a beginning with no before is perplexing. We're wired to ask what happened next, but with the Big Bang, we're forced to ask what happened first. It's a conundrum that challenges our very understanding of the nature of reality, yet we don't shy away from this enigma. Instead, we delve deeper, peering into the abyss of the unknown with a sense of awe and curiosity. From quantum fluctuations to multiverse hypotheses, we explore a myriad of theories, each more fascinating than the last. And with every step forward, we inch closer to understanding the origins of existence. So let's delve into the various theories that attempt to answer this enigmatic question. Let's embark on this journey, not because it's easy, but because it's hard. Because that challenge is one that we're willing to accept, one we're unwilling to postpone, and one which we intend to win. So fasten your seatbelts, it's going to be a mind-bending ride. The first theory that scientists propose is the Nothingness Hypothesis. This posits that before the Big Bang there was simply nothing, not a void filled with darkness, not an empty space waiting to be filled, but absolute nothingness. Now, to comprehend this, we need to revisit Einstein's theory of general relativity. This groundbreaking theory dramatically redefined our understanding of gravity, space, and time. It proposed that space and time are interwoven into a single continuum known as space-time. Now, if we trace back the path of the universe using this theory, we arrive at a singularity, a point in space-time where the curvature becomes infinite. So in the context of the Big Bang, this singularity is the beginning. Before it, there's no before. It's a bit like asking what's north of the North Pole. The question itself becomes meaningless. This is the essence of the Nothingness Hypothesis. Our universe, according to this hypothesis, is finite. It had a definite beginning and will presumably have an end. But this theory isn't without its controversies. Some scientists argue that general relativity, as brilliant as it is, isn't equipped to probe the extreme conditions of the singularity. It falls short in explaining the quantum effects that would have dominated the physics of such a tiny, dense point. This is where the limitations of the Nothingness Hypothesis come into play. Furthermore, the notion of absolute nothingness is a challenging one, not just scientifically, but also philosophically. It's hard to imagine nothing, not just emptiness or void, but an absence of everything. It's a concept that truly tests the limits of our understanding and imagination. The Nothingness Hypothesis, therefore, offers a fascinating yet contentious perspective on what existed before the Big Bang. It's an exploration of the extreme, of the very boundaries of our understanding of the universe. But is nothingness the only possibility? Surely there are other theories. Another intriguing theory is the quantum fluctuation theory. This theory offers a unique perspective on the origins of our universe, suggesting that the Big Bang was not a singular event, but rather the result of a random quantum fluctuation in what is known as a timeless quantum vacuum. To understand this, let's first delve into quantum mechanics, the field of physics that explores the behavior of particles at the tiniest scales. Quantum mechanics tells us that on these minute scales, particles can pop in and out of existence seemingly out of nowhere. This is what we call quantum fluctuation. In essence, the quantum fluctuation theory suggests that our universe could have originated from one of these random, spontaneous events. Imagine a timeless quantum vacuum, a sea of nothingness where these fluctuations are occurring. Suddenly, one of these fluctuations sparks the creation of an entire universe, ours. From this perspective, the Big Bang was not a beginning, but rather a transition from one state to another. This theory implies an infinite universe where countless fluctuations are constantly giving birth to new universes in a cosmic landscape beyond our comprehension. It's an idea that pushes the boundaries of our understanding, turning the concept of before on its head and challenging our perceptions of time and space. However, like all theories, the quantum fluctuation theory is not without its limitations and controversies. Critics argue that it's based on speculative extrapolations of quantum mechanics, a field that, while incredibly successful in its own domain, has yet to be reconciled with our understanding of gravity and the larger universe. Moreover, the notion of an infinite universe raises philosophical questions that science is yet to answer. Despite these challenges, the quantum fluctuation theory offers a fascinating lens through which to explore the origins of our universe, inviting us to question, to wonder, and to probe the very fabric of reality. It's a reminder that the mysteries of the cosmos are far from being fully unraveled. Yet the mysteries of the pre-Big Bang universe don't stop here. The multiverse hypothesis is another compelling theory. This conjecture suggests that our universe may not be the only game in town. Instead, it's part of a grand cosmic ensemble, a multiverse with an infinite number of universes coexisting side by side. Now, imagine galaxies, stars, planets, even entire civilizations not bound by our universe's physical laws, but operating under entirely different sets of rules. It's a mind-boggling concept, isn't it? This is what the multiverse hypothesis proposes. This hypothesis is deeply rooted in string theory. The theory posits that everything in the universe, from the smallest particle to the largest galaxy, is composed of tiny, vibrating strings of energy. These strings vibrate at different frequencies, and it's these frequencies that determine the properties of the physical universe. String theory also suggests that there are more dimensions than the three of space and one of time that we're familiar with. Now, here's where the multiverse comes in. If these extra dimensions exist, then it's possible that there are other universes out there, each vibrating at its own unique frequency, each with its own unique physical laws. But the multiverse hypothesis isn't without its critics. Some argue that it's more of a philosophical concept than a scientific one, as there's currently no way to test or observe these other universes. Others question whether string theory itself is even correct, as it's yet to be confirmed by experimental evidence. Despite these controversies, the multiverse hypothesis continues to captivate scientists and laypersons alike. It challenges our understanding of reality and pushes the boundaries of what we thought possible. It's a testament to humanity's insatiable curiosity and our relentless pursuit of knowledge. And so the journey into the pre-Big Bang universe continues to baffle us. But isn't that what makes exploring the cosmos so incredibly fascinating? The more we learn, the more we realize just how much there is left to discover. As we've seen, the question of what existed before the Big Bang is both fascinating and complex. This final scene draws together the threads of our cosmic journey, reminding us of the key points we've explored and the theories we've considered. We began with the Big Bang Conundrum, the perplexing question of what could have possibly existed before our universe sparked into existence. This led us to the Nothingness Hypothesis, where we pondered the idea that perhaps before the Big Bang there was simply nothing, no matter, no energy, no time, no space. Yet the quantum fluctuation theory offered a different perspective. Here we delved into the realm of quantum physics, considering the possibility that the universe may have arisen from a tiny random fluctuation in a quantum field, a spark from nothingness that gave birth to all we know. The multiverse hypothesis, our next stop, took us even further into the realms of speculation. Perhaps our universe is but one bubble in an infinite cosmic foam, one of countless universes born from an endless cycle of big bangs and big crunches. Each theory, from the nothingness hypothesis to quantum fluctuation and the multiverse hypothesis, offers a unique lens through which to view the pre-Big Bang universe. Each contributes to our understanding of the cosmos, pushing the boundaries of our knowledge and firing our imagination with new questions and possibilities. But perhaps most importantly, these theories remind us of the power of human curiosity, our insatiable desire to understand the world around us and our place within it. They reflect our quest for knowledge, our determination to unravel the mysteries of existence, and our courage to probe the unknown. In the end, Probing the mysteries of the pre-Big Bang universe is a testament to human curiosity and our unending quest to understand the origins of existence.